So next topic, EMF equation of the transformer. So this is very important question, derivation, EMF equation derivation for the transformer. Let us draw the transformer symbolic representation. So transformer consists of two coils, primary and secondary, or two windings, primary winding and secondary winding. So those two you can represent like this, and core is represented by these two lines. This is core and these two are windings. And to this winding I am giving AC voltage. So AC supply. So due to the AC voltage, current will circulate in this. So let us assume that current is I1. This is primary and this is secondary. The winding which is connected to alternating voltage is nothing but the primary winding, and the other winding is called secondary winding. And let us assume the number of turns in this case is N1. For primary coil, the number of turns, assume it as N1, and for secondary, number of turns N2. And I am connecting a load here to the secondary of the transformer. So now what will happen according to principle of operation or Faraday's laws of electromagnetic induction? Due to this alternating current, a flux phi will be produced. Right? So that flux is alternating in nature, d phi by dt, means change in flux. That change in flux is linking with the coil, therefore EMF gets induced in this coil, that is E1. And this flux not only links with the primary, it will also links with the secondary coil. Then EMF gets induced in the secondary winding also, that is, let it be E2, induced EMF in secondary. Now this secondary circuit is a closed circuit. So due to this EMF, now current will circulate in the secondary winding. So let us assume that current is I2. Here let us assume E1 is the RMS value of the primary induced EMF. These are AC quantities. So AC we have to take RMS values. So I am assuming this induced EMF E1 is the RMS value of the primary induced EMF. And E2, it is also the RMS value, the induced EMF, that is for secondary induced EMF. And N1, number of turns of primary winding, number of primary winding turns. And N2 is number of secondary winding turns. So what we are going to do, we are going to derive the equation for this induced EMF E1. So further, just assume what is happening in the transformer and the quantities, number of turns and induced EMF, those terms, just assume it. And you need to know the principle of operation of the transformer to derive the EMF equation. So now the primary winding is excited by purely sinusoidal quantity, that means AC supply. Hence the flux produced is also sinusoidal in nature. You are giving alternating voltage, AC voltage. So due to this alternating voltage, you will get alternating current. So due to this current, flux is producing. So that flux is also alternating in nature. So why? Because whatever the current nature, the same nature the flux will also have. So nature of flux depends upon the nature of current. So let us assume I is equal to current equation I am writing. So mathematical expression for current is Im sin omega t. This is the mathematical equation for the alternating quantity. If it is voltage, Vm sin omega t. So here current, so I am taking Im sin omega t. So this current is flowing through the primary winding. So this is the current flowing in primary winding. So then what will happen? So whenever the current is flowing in the primary winding, due to that current, flux will be produced. Right? So the flux produced is if current is alternating in nature, flux is also alternating. So flux equation what will be? It is phi is equal to phi m sin omega t. This is the equation for the flux produced in the primary winding. Here phi m is nothing but maximum value of the flux. Im is nothing but maximum value of current. So in the same way, phi m is nothing but maximum value of flux. I have E1 and E2. These are RMS values. Now what I am doing, I am going to assume the instantaneous values of the induced EMF. Let E1, E1 is the instantaneous value of the induced EMF in primary. And the same way E2 is the instantaneous value of the induced EMF in secondary. Now what will happen once the current is given? So due to that current, flux is produced. Now according to Faraday's laws of electromagnetic induction, EMF gets induced in the primary winding. So that EMF, the magnitude of the induced EMF is given by, what is the EMF equation formula? E is equal to d psi by dt. Here psi is nothing but total flux. So this is the EMF equation given by Faraday. So according to Faraday's laws of electromagnetic induction, EMF gets induced so EMF will be induced, and that magnitude of EMF, the magnitude of EMF is given by, let us assume E1 in primary, that is E1 is equal to d psi by dt. In the same way, E2 is equal to, again this is d psi by dt. Both are induced EMF only. A d by dt of, here psi is nothing but total flux linkages. So total flux means phi is the flux per turn. For one turn, flux is phi. Here, how many number of turns are there in case of primary winding? N1 number of turns are there. Then what will be the total flux? Total flux in case of primary? Psi is nothing but total flux. Total flux in primary winding. And here, in case of E2, phi means total flux in secondary winding. So I'm saying phi is flux per turn. Then what is the total flux in primary winding? Anybody? N1 pi, very good. So for one turn, flux is phi. So in primary, N1 number of turns are there. So N1 into phi is the total flux. So then it will become N1 d phi by dt. In the same way here also, d by dt of total flux in secondary will be N2 into phi. Again, phi is the flux per turn in case of secondary also. But number of turns for secondary is N2. So total flux will be N2 into phi. So N2 d phi by dt is the induced EMF in secondary. So this is the magnitude of the induced EMF. But the direction of induced EMF is given by Lenz's law. Direction of induced EMF is given by, this is alternating quantity. Alternating quantity means it is having both magnitude as well as direction. What is Lenz's law? I already explained this Lenz's law. What is the statement for Lenz's law? Lenz's law states that always effect opposes the cause. Lenz's law is nothing but always effect opposes the cause. What is the effect here? What is the effect and what is the cause? Induced EMF, that is nothing but the effect. Finally, you are getting that one, EMF. What is the cause to induce that EMF? Change in flux. If there is no change in flux, there will not be any EMF in the coil. So here effect is nothing but the EMF. Effect is EMF and cause is change in flux, that is d phi by dt. So always this effect opposes the cause. Then how can you show that one? By putting a minus sign here, minus n1 d phi by dt. Here minus sign indicates that effect or EMF opposing the change in flux. So we know that phi is equal to, what is the equation we have? Phi is equal to phi m sine omega t, right? So I am going to substitute that phi in this equation. E1 is equal to minus n d by dt of phi m sine omega t. So minus n1, phi m is also constant, you can write it outside, d by dt of sine omega t. What is the differentiation for sine? Cos omega t. So for omega t, it is omega. You are differentiating with respect to t, not omega t. So for omega t, differentiation is omega. So minus n1 phi m omega into cos omega t. This is E1. Now what I am going to do is, I want to remove this minus sign and this cos. I want it in terms of sign to compare with the standard equation. Standard equation for alternating quantity is in terms of sign only, sine omega t, and there is no minus sign also. So for that, n1 phi m omega, this cos omega t, can we write it as sine? Cos theta is equal to sine 90 minus theta. Is it right?
Pi by 2.
Suppose if you took common here, minus of theta minus 90, then it is sine of minus theta minus sine theta, right? Sine of theta minus 90. Is it correct? Cos theta, you can write it as sine 90 minus theta. And again, the 90 minus theta, I am taking minus as common here. Then it will become theta minus 90. So sine of minus theta is nothing but minus sine theta. So that is what I am writing here, minus sine theta minus 90 degrees. So here you got cos omega t, what we are getting here, minus sine theta minus So in place of theta, what you have to write? Omega t here. Omega t minus 90 degrees. Minus into minus, it will become plus now. N1 phi m omega into sine omega t minus 90 degrees. So this is EMF equation. So similarly, E2 will also, E2 is equal to, in place of N1 you will get N2. N2 phi m omega sine omega t minus 90. No need to derive like this. You can write it as similarly, E2 is equal to N2 phi m omega sine omega t minus 90. But what I need, EMF equation is even, RMS value I want. RMS value is even. How can you get even RMS value? What is the formula for RMS value? Maximum value by root 2. I forgot it. Even is nothing but RMS value. So RMS value is nothing but maximum value by root 2. RMS value of a sinusoidal quantity is nothing but maximum value by root 2. Here even is the instantaneous value. So instantaneous value, mathematical expression is what? E of t is equal, or V is equal to Vm sine omega t. So if you compare these two, what is the maximum value in case of E1? E1 is N1 pi m omega sine omega t minus 90. What is the maximum value here? This total thing is the maximum value. In place of Vm, you have N1 pi m omega. So remaining sine omega t minus 90. So omega t plus or minus 90 you can write, standard equation. So what is the maximum value we have here? N1 pi m omega by root 2. So in place of omega, you can again substitute N1 pi m 2 by f by root 2. So 2 will get, so it become root 2 N1 phi m pi f. So root 2 into pi, value you will get it as 4.44 phi m f n1. So this is the induced EMF units volts, 4.44 f nm, sorry, f pi m into n1. So if it is E2, in place of n1 you will get n2. So that is only the difference. So this is the EMF equation of a transformer, 4.44 phi m f n1, and E2 is equal to same expression, in place of n1 you will get n2 volts. Have you understand the derivation? So go through the derivation today. If you have any doubts, ask me tomorrow.